Hari Raya Mimi. Selamat Hari Raya Auntie. I have great raya for you. Thank you. Thank you Auntie. Auntie, can I ask you one question? Sure. What is it? Why in Hari Raya people are giving us duit raya? What for? Oh, it is because we want to share our sustenance and happiness with other people. Apart from that, by doing this, we also can improve our bonding. I see. Thank you, Auntie.
Assalamualaikum and hi everyone. My name is Teacher Mira. I hope that all of you are in the pink of health after coming back to school from the Raya break. The topic for today's class is chemical bonds, which are hydrogen bonds and dative bond. Currently, we are still in chapter 5 and we will continue with our subtopics, which are 5.4 and 5.5. It is still with the sharing, donating of electron, and today we have some new addition, which is attraction forces. So, are you guys ready? If yes, let's get started.
The first topic is hydrogen bond. Our learning objective for this topic are: at the end of the lesson, you should be able to first explain with example the formation of hydrogen bond. Second, explain the effect of the hydrogen bond on physical properties of the substances. Did you all know what is a hydrogen bond? Hydrogen bonds are the attraction forces that occur between a hydrogen atom that bonded with a high electronegativity atom. Examples of high electronegativity atoms are fluorine, oxygen, and nitrogen. Based on the definition, we can see that to form a hydrogen bond, there are two requirements that must be fulfilled. First, the molecule must contain a hydrogen atom. Second, the hydrogen atom must attach with one of these three high electronegativity atoms, which are fluorine, oxygen, or nitrogen. So, I want you to think for a while. If only one requirements are fulfilled, can it form a hydrogen bond? The answer is no, it cannot form a hydrogen bond. Why? Because you need to remember, to form a hydrogen bond, both of the requirements must be fulfilled. Are you guys clear so far? So let's see the example for better understanding. As you can see, these are two water molecules. Hydrogen bond can occur here because it fulfills the two requirements needed. The attraction forces occur between the hydrogen atom from the first molecule and the oxygen atom from another molecule that form a hydrogen bond. Now let's check your understanding.
Determine the bond at the arrow pointing. Is that a hydrogen bond or not?
You already know about hydrogen bond, right? But did you know what is the role of hydrogen bond in our daily life? Let me show you this image. Did this situation seem familiar to you? Why did our hair stick together when it is wet? The answer is due to the hydrogen bond. For your information, our hair are made up of 85% of protein, which is keratin. When our hair is dry, the protein molecules form hydrogen bond among one another in the hair structure. But when our hair is wet, due to the presence of water, the protein molecules are no longer form the hydrogen bond among themselves. Instead, the protein molecule will form the hydrogen bond with the water molecule, and then this water molecule will also form the hydrogen bond with the other hair protein molecule. So that what is the reason why our hairs stick together when it is wet? Now let's see the effect of hydrogen bond on the physical properties of substances. First, boiling point. As you can see, the boiling point of ethanol is much higher compared to chlorine. If you still remember, the compound in the form of liquid will reach the boiling point when the attraction forces between molecules are all overcome. For the ethanol, there are hydrogen bonds formed between molecules other than the weak van der Waals forces. And for your information, hydrogen bond is a strong bond and it is difficult to break. So more heat energy is required to overcome the weak van der Waals forces and also to break the hydrogen bond. Due to this, the boiling point for ethanol is higher compared to chlorine because chlorine do not form hydrogen bond at all. Second, solubility. Ethanol is soluble in water. This is due to the formation of hydrogen bond between ethanol molecule and the water molecule. Next, we proceed to 5.5, which is dative bond. The learning objective for this topic is, at the end of this lesson, you should be able to explain with example for the formation of dative bond. Before that, I want to check. Are you guys still with me right now? I want you to hang on because just a little bit more and I want you to stay focused. Okay, let's start. For the definition, dative bond or the other name, coordinate bond, is a type of covalent bond where the electron pair that is shared comes from one atom only. It is quite confusing, right? But don't worry and don't panic. Let me explain to you and make it more clear for you. Previously, you already learned about covalent bond. But the covalent bond that you have learned before is a normal covalent bond. Dative bond is a special covalent bond. Now, let's see the differences between dative bond and covalent bond. So, for the normal covalent bond, the amount of electrons that have been shared between both atoms are equal. It means that if atom A shares one electron, so atom B will also share one electron to achieve their stability. Fair and square, okay? Next, the special covalent bond or dative bond, it only requires one atom to share the electron, not both of the atoms. It means that when atom A shares two electrons, so atom B doesn't have to share any electron. Atom B just need to accept the shared electron by atom A to achieve its stability. Can you see the differences now? Let's proceed with the example. This is the formation of dative bond in the hydroxonium ion. Hydroxonium ions are formed by water molecule and hydrogen ion. In the water molecule, the oxygen atom and hydrogen atom are already achieved the octet and duplet electron arrangement. But as you can see, the hydrogen ion doesn't have any electron in the shell. So the solution is the lone pair of electrons that are not involved in the covalent bond in water molecule will be shared with the hydrogen ion through the formation of dative bond. Now, in the hydroxonium ion, the oxygen atom and all of the hydrogen atom have achieved the stable octet and duplet electron arrangement respectively. So, that is how the dative bond was formed. By the way, I have one video that I want to share with all of you. But while you are watching that video, I want you to relate the situation with the dative bond.
What do you want to do for your birthday?
But that's not possible.
If it was possible, what would it be?
I'm homeless right now, man. Look, I live out of a box.
Since it's your birthday today, I have $1,000 here for you.
What?
I'm dead serious, man.
Are you kidding me, man? No, ain't giving this to me. I'm using this for a place to live.
Can I give you a hug by any chance, Ken?
Yeah.
Happy birthday.
Thanks, man.
Here we go again, summary time. So today we have learned about another two bonds, which are hydrogen bond and dative bond. Hydrogen bonds are formed when one hydrogen atom is attached to one high electronegativity atom such as fluorine, oxygen or nitrogen. And hydrogen bond is a strong bond, so to break the bond, a high heat energy is needed. Next, we also have learned about dative bond. Dative bonds are formed when only one atom shares the electron, while the other atom doesn't share any electron to achieve stability. So, I hope all of the learning objectives are successfully achieved. I see you guys in the next class. Thank you and have a nice day.